Which of the following phenomena are based on Bernoulli's principle? So here all are based on Bernoulli's principle only. Fourth option is correct. It is a theoretical question, but still I will give rough idea about all the terms. So here the velocity of a flux is the velocity with which liquid come out of hole carved some height from the bottom. Bernoulli's equation here P plus half rho v square plus rho gh is constant. Here, when water is coming out of this, here there will be atmospheric pressure enter with v1 velocity. Here pressure, here it comes out with velocity v2, and liquid levels are at different height. By using this, we can find velocity of a flux. So Venturi meter also like that. Venturi meter is device that measures rate of flow of fluid through the pipe. So this also works based on Bernoulli's. The Magnus effect also. Just I will write few words here. Fluid pressure decreases at the points where the speed of fluid increases. All these are based on Bernoulli's theorem only. 200 grams of ice at minus 20 degrees. Here, to solve this kind of problems, one reference level is important. That is, I will take reference level as water at 0. So left side, 200 grams of ice at minus 20 degrees centigrade is mixed with 100 grams of water at 60 degrees centigrade. So specific heat of ice is 0.5 calorie per gram Kelvin. Specific heat of water 1 calorie per gram Kelvin. Final temperature. So if complete ice melts and still energy is left over, it will rise to some temperature. If complete ice is not melt, then temperature will be at 0 degrees centigrade. When comparing to the water at 0 degrees centigrade, what is the energy 100 grams of water at 60 degrees Celsius? That is 100 into specific heat of water, that is 6,000 calories. So to melt here, First stage, 200 grams of ice at minus 22, I set 0. That is 200 into 0.5 into 20. That is 100 into 20, 2000 calories. But even if this energy is utilized, still 4000 calories are there. Now 200 grams of ice at 0. So what we did is, once if you give 2000 calories, this 200 grams of ice at 0, 200 grams of ice at minus 20 will be converted to 200 grams of ice at 0. To convert in terms of water, so for keeping temperature same, for one, this is latent heat of fusion. To convert 1 gram of ice at 0 to water at 0, 80 calories are required. 200 grams amount of energy required is 16,000 calories. The available energy is only this much. To convert ice into water, you require minimum 2000 plus 16,000, 18,000 calories. But available is 6,000 calories only. 2,000 calories are utilized to convert ice at 0. Remaining 4,000 calories. 4,000 calories are available. So 80 calories per 1 gram. That means 50 grams of ice melts and still 150 gram of ice is left over. That means as ice is left over, resultant temperature is 0 degrees centigrade. So first option is correct. Here, 3 metallic rods of identical lengths are welded together to form the letter Y of English alphabet. This type of problems, Kirchhoff's law. So rate of flow of heat, that is, let us name it as ABCD. So heat current enters B, that is measured as K into delta theta by L. Here it is 60. It is junction temperature theta. Ka by L 60 minus theta. He told metallic rods of identical lengths. Here this heat current, it enters as I. It leaves the junction. So across different rods by flowing different heat currents. So heat current leaves junction B, that is I1, say this is I, which is here, I will take this as K1, which is K. So here I1 is K2 into, since identical rods, same area of cross section, theta minus 51, identical rods, same length. But K2 here is 2K, theta minus 51 by 1. Heat current leaves across BD rod is I2, which is K3 into A, theta minus 20 by L. And this constant 3Ka into theta minus 20 by. So different coefficient of thermal conductivities. So entering current is equal to leaving current Ka by L 60 minus theta Ka by L 2 theta minus 51. It is 2 theta minus 51, 3 theta minus 60 Ka by L everywhere. So 2 theta minus 102. Here it is 5 theta. 6 theta is equal to 60 plus 102. Here it is 3 theta minus 60. So how much it is? It is 60 minus theta. 2 theta minus 102, 3 theta minus 60. 60 plus 102 plus 60. How much it is? 222. Theta is equal to 222 by 6. So that is 37 degrees. Second option is correct. Here, the symbolic representation of the network, various logic gates are given. So you have idea about NOR gate. NAND and NOR are universal gates. So it is negation of OR gate. So here two different input signals are given. Output signal will be right x plus y bar. But here when these ends are connected, this NOR gate works as NOT gate. So here is input signal. It is output signal will be its negation here y through this input signal. Here it will be its negation. So that is x plus negation will be dot y. Again, that is again send along NAND gate, right? So that is also here output will be x dot y negation. That is finally x plus y. It works like a OR gate. Here, because recently they are giving theory questions in the first mains. So better to concentrate on theory questions also. Sound waves are both longitudinal and transversal. But here the speed of mechanical waves is maximum. So what is the difference between solids, liquids, gases. Here, molecules are packed very nearer. Liquid separation between them is more. Gases, more separation. So sound is nothing but it's a disturbance whose propagation is facilitated by collision between particles. So this molecule hits this molecule, another molecule hits another molecule. So that is fast process in solid because these molecules are dense in the solid. So when compared with liquids and gases, so obviously speed of sound is more in solids. But here, so these options are not correct, but he given third and fourth, if you carefully observe, transfer wave in solid and longitudinal wave in solids. So here longitudinal means here how to separate. So the speed of mechanical waves, transverse wave in solid has more speed or longitudinal wave in solid has more speed. So this one, longitudinal wave travels parallel to direction of propagation and hence it enter in solid medium without wasting much energy. Whereas transverse wave, it oscillates perpendicular to the direction of propagation and it vibrates the solid atoms which acts as resistant for the moment. So transversal wave move lesser speed, longitudinal wave will move with more speed. Fourth option is correct. A thin biconvex lens is kept on a clean mirror when an object is kept at 20 centimeter in front of the lens. The image is formed at the same point. Here is a plane mirror. This one is biconvex lens. Right. When an object is kept 20 centimeter in front of the lens, its image is formed at the same point. So ray from the source incident on the lens get refracted, and after two successive refractions, if it incident normally on the plane mirror, then the rays which are parallel rays coming from infinity, after two successive refractions, it again meet at the same point. So here major point is you get image, so where object is placed, that is obtained when two successive rays, here the rays which incident on the surface of a convex lens get refracted, and after refraction from the second surface, if it is incident normally, then parallel rays, after again two successive refraction, again they converge at this point. That point is focus. So, so here object distance is same as focal length, which is 20 centimeters. To do here, circular disk of radius of gyration 20 centimeter at rest. Dropped over another disk of same mass but double the radius of gyration. Which is rotating with 5 radian per second. So once it is gently placed over another disk, no external force, torque, angular momentum is conserved. So that is 2 is nothing but dl by dt, which is L is constant. So I1 omega 1 plus I2 omega 2 is here I1 plus I2 of omega. So after placing, so they rotate together about a common axis. Here I1, which is first one having 20 radius of gyration as 20 centimeter at rest. So here I is nothing but mk square. K2, let us say. K2 here is double the radius of gyration, that is 2k1, which is 20. So here I1 is mk1 square, I2 is mk2 square of omega. So here mass is same. K2 is 2K1. Then here M 4K square omega initially, which rotates with 5 radian per second. Here it is mk square plus m into 2k whole square. That is, let us write K2 as 2k, 4mk square of omega. So m get cancelled, 4k square omega 2, which he given 5 radians, which is 5m, m anyhow get cancelled out, 5k square omega. So both the disks move with an angular speed 4 radians per second. Here, in the simple harmonic motion displacement equation, he given 8 sine omega t. So that oscillate about mean position like this. And another one, this is 8m sine pi by 2 plus omega t. You can consider. So another particle displacement like this. Another is omega t plus pi. Here maximum displacement is 8, here 8. Another one, that is 90 plus 90, here pi. So 2 meters. Net displacement in this direction is, that is 6 meters. Here amplitude is 8 meters. These two are perpendicular. Resultant amplitude will be root of 8 square plus 6 square, that is 10 units. So here a large simple pendulum of length of equal to radius of Earth is making simple harmonic motion. For a large simple pendulum, time period, we have a formula Re by 1 plus Re by L of G. Pendulum of length equal to radius of Earth, that is Re by 1 plus Re by Re of G, which is nothing but Re by 2G. That is 2 pi also will be there. So radius of Earth, you know it, 6,400 kilometers. G, if you take 10, so it is 2 pi into root 32 into 10 power 4. So 10 square into 2, 200 pi, root 16 into 2, 4 root 2. So which is 800 pi root 2 seconds. So by in terms of here 3 into pi is 3.14, it is 1.4. So roughly 44 by 60 minutes. So here, even if you take 4, 6, 7, 42, so it is roughly 58 minutes. Roughly we can fix exactly simplification. It is giving 59.3 8 minutes, which is nearest integer's answer is 60 minutes. At constant pressure and monatomic ideal gas is heated from temperature T1 to T2, it does 40 joules of work. So at constant temperature pressure, where dq is du plus dw, then cv delta t, it does 40 joules of work. Cv here is R by gamma minus 1. It's a monatomic gas. For monatomic, gamma is F is 3 degrees of freedom. So it is 3R by 2. So dW is nothing but NR delta T. So dQ will be NCV, I can replace with 3R by 2 delta T plus 40, which is 3 by 2 NR delta T plus 40. So that is already given as 40. So which is heat supplied is 100 joules. Yeah. So particle undergoing simple harmonic motion in a straight line with a time period 3 seconds. That is for 1/4 oscillation. For 1/4 oscillation, it takes t by 4 seconds. That is 3 by 4, 0.75 seconds. But it make 3 by 8 oscillation. 3 by 8 minus 1/4. So it is 1 by 8 oscillation still left over. From A to B, it is 1/4 oscillation. And 1 by 8 means half of this. So for 1 by 8 oscillation, finally, the particle which executing SHM is exactly half the distance from the mean position. And particle starts from extreme. We use a formula. So it is at half of the amplitude. We write cos omega t is half, omega t is pi by 3. We get here t as 3 by 2. T here is 3 into 2, 6 by t. Right? Sorry. T here is t by 6, that is 3 by 6, half, 0.5 seconds. So total time taken for t by 8 oscillation is 0.75 plus 0.5, 1.25 seconds. So in this 27th problem, So it's a binding energy of nuclei. Two nuclei combine together and form another nuclei. So in this fusion process, so energy is released since nuclear binding energy rises with hike in the mass. So here, initial binding energy is binding energy of P plus binding energy of Q, that is 112 plus 106, 208 million electron volts. So final binding energy will be 230 million electron volts. So energy released will be 238 minus 208, 12 million electron volts. A reading of the ammeter, ideal ammeter in the circuit. So what is the net current flows through it? When current flows through the battery, so when compared with this resistor and this wire without resistance, obviously, so where zero resistance is there, maximum current flows through this, we can neglect it. Again, here, the same thing will happen at this point. So here is a conducting wire without resistance. So current will not flow through this, only current flows through this. Then a final resistance will be here. So let us calculate effective resistance between these points. Here between A and B, there is one resistance. Between A and C, there is another resistance. Or between B and C, you have another resistance. Between C and D, so there is resistance R. Between B and D, you have a resistance. Between C and D also, you have a resistance. So here it is, Wheatstone bridge balances. You can remove this. Then these two are in series. Effective resistance 2R. So these two are in series 2R. Since they are connected in parallel between A and D, two equal resistances are connected in parallel. So effective resistance is half of it. So which is R. So now, so final resistance will be R plus 2R. Here R, this is 2R, which is 3R. So now the current which flows through this will be 10 by 3 amperes. So it is 10R by 3. Here it is 2R. Sorry, R plus R. Effective resistance is R, and there is another resistance is R, which is 2R. So here it is 10 by 2R. Resistance is given as 5 ohms. The current which flows through the circuit is 1 ampere. So ammeter reading is 1 ampere. Here the potential difference between X and Y in the circuit. Let us take point C here. So if you apply Kirchhoff's second law, VC minus 80, if you take the path like this, which is equal to 100 I1 plus VC. VC plus 80. That is, let us take the path as AXB, CAXB path. So I1 here is 4 by 5 amperes. For CAYB, so VC plus 80, here I1 current flows through it. When resistors are connected in parallel, current will be distributed 30 plus 10, 40 I2 plus. So I2 here is 2 amperes. Now to find out potential difference between X and Y, VA minus 50 I1 is equal to Vx. That is, potential drop across the resistor is this. I1 is 4 by 5, that is 40 volts. Similarly, VA, if you take this path, VA minus potential drop across this will be Vy. So VA minus Vy will be 30 I2, that is 60 volts. So subtracting one from other, VA minus X minus VA minus Vy is here 40 minus 60 minus 20. That is potential difference across. So those 2 points X and Y will be 20 volts. Here it is. And two inductors are perfectly coupled. If a current 2 amperes is reversed in first coil, then EMF induced. So if changes occur in one coil affects the other coil, problem is related to mutual inductance. So EMF induced in second coil is minus MDI by, in fact it is d by dt of flux, which implies magnitude of EMF is d by dt of Mi. M stands for mutual inductance, di by dt. Here current is reversed. Here di means change in I. Originally current flowing in this direction, it gets reversed. Change will be minus 2 minus of 2 by dt. So it is 4m by dt. So this time he given it as 2 millisecond, 10 cube into m. And since he told it is perfectly coupled, so m is equal to root of m1 into m2. That is 18 into 8, it is 12 millihenries. So now EMF induced will be 10 cube, where it is also current is amperes. Okay, 10 cube into 12 millihenries. So that is EMF induced is